Welcome back. This is our video solution to problem 3 from Superquiz 1. We're moving on from sets to relations and functions. Of course, relations and functions are defined on sets, right? From sets to sets, etc. And here, looks like the sets we're defining our functions or relations on are going to be first A, which is the first, looks like 6 letters of the alphabet, and then B, which would be the first 6 positive integers. All right, it says for each of the following sets, okay, I see sets down here, determine if the set is a relation from A to B. Okay, well, what was a relation? So a relation, it's called R, is a subset of the Cartesian product. So it's a set whose elements are pairs, right? So this would be a relation from A to B. The first component of the pair should be an element from A. The second component should be an element from B. And that generally speaking, looks like what we got, right? Let's take a quick peek through these. So first, everything in the first component should be from A, which is A, B, C, D, E, F. And everything in the second component should be from B, 1, 2, 3, 4, 5, 6. So let's look at the first component, C, D, A, F, B. Yep, we're good. 2, 4, 1, 3, 6. Yeah, no problem there. So this is a relation. Okay, how about the second one? A, B, C, D, E, F. Perfect. 1, 2, 3, 5, 6, 7. Wait, 7? Oh, yeah, 7 wasn't one of the elements from B. So B is not a relation. Not a relation, right? It has to actually be a subset of the Cartesian product. The second component has to be from B. This is not an element of B. Okay, let's look at C. A, B, C, D, E, F. Beautiful. 6, 5, 4, 3, 2, 1. Cool, just in reverse order. A, B, C, D, E, F. Same thing. Good. 4, 4, 4, 4, 4, 4, 4. A, 4 is in there. We're good. A, B, C, D, E, F, A. Okay, it occurred twice, but it's still in A. That's okay. 1, 2, 3, 4, 5, 6, 6. Again, something occurred twice, but that's not a problem. Okay, so all 3 of these are relations. Okay, next it says, for those that are, right, assuming that means are relations, determine if it is a function, injective, surjective, and or bijective. Okay, well, let's put up here, function, injective, surjective, and bijective. Okay, now, the important thing for being a function is that you cannot have the same element of A paired off with more than one element of B. And every element of A does have to get paired off with at least one element. If you want to combine those two statements, you're saying every element of A has to be paired off with exactly one element of B. So let's check. Well, maybe we should do it in alphabetical order. So first we have A with 1, cool. B with 6, C with 2, D with 4, and oh, I can't find E. E isn't paired with anything, so this is not a function. Okay, so for A, E has no image, right? So that's kind of the language we can use. So not a function, right? Not a function. Okay, how about B? Well, we don't have to check B because B is not a relation. So, all right, let me, instead of using an X here, we'll use check mark, right? Because it was, oh, no, wait, that's right. We said it's not a function. Cool, X marks. Okay, how about C? Okay, we have A with 6, B with 5, C with 4, D with 3, E with 2, F with 1. Cool. You don't see A, B, C, D, E, or F show up twice, and they do show up at least once. So C is a function, right? We don't need to worry about that line. So C is a function. How about D? Well, again, A, B, C, D, E, F, they all show up exactly once. So this is a function. How about E? A, B, C, D, E, F. Uh-oh. A shows up twice, and it has 2 different images. That means it's not a function. All right, so for part E, A has 2 images, which implies not a function. Okay, how about injectivity? So injectivity means that if you take any of the elements of the codomain, right, that's the B, it has at most one preimage, right? It can only show up at most one time. Now, it doesn't have to show up at all. That's fine. But if it does show up in the second component, it can only show up once. So let's see. 1, 2, 3, 4, 6. Yeah, nothing shows up more than once. So this is injective. How about C? Well, let's see. 6, 5, 4, 3, 2, 1. Yeah, nothing showed up a second time. So this is injective. All right, how about this one? 4, 4. Well, I mean, they're all 4, right? 4 shows up every single time. This is like the antithesis of injective, right? This is as worst as it could possibly be. So not injective for D. So let's put that in here. So 4 has multiple preimages. Okay, so the preimage of 4 is, well, it's all of them. It's the set containing A, B, C, D, E, and F. Has multiple preimages, which implies not injective. Okay, and then we don't have to check this last one. Or no, we can. It's a relation, so we can check it for injectivity. Let's see. 1, 2, 3, 4, 5, 6, 6. Oh, 6 shows up 2 times. So this is not injective. So for E, we can put in here 6 has 2 preimages, which implies not injective. Okay, now we move on to surjective. Now surjective is like injective, only instead of saying at most, you have to say at least. So every element in the codomain has to show up in the second component at least once. So for this first one, okay, we need to find all of them. Well, let's see. 1, 2, 3, 4, 6. There's no 5. 5 doesn't show up. It doesn't have a preimage. So this relation is not surjective. So for A, we can say 5 has no preimage, which implies not surjective. Okay, how about, well, we can skip B. How about C? Okay, well, we have 1, 2, 3, 4, 5, 6. Yeah, every one of them shows up. So it is surjective. Okay, D. 4, 4, 4, 4. Wait, only 4. 4 is the only element that has a preimage. So this is, again, really close to as bad as you can, almost as bad as you can hope for in terms of surjectivity, right? So this is not surjective. So D, only 4 has a preimage. So this implies not surjective. Okay, how about E? 1, 2, 3, 4, 5, 6, 6. Hey, 6 showed up twice, but we don't care because surjective only asks you for everything to show up at least once. Doesn't care if it shows up more than once, and everything did. 1, 2, 3, 4, 5, 6. So we do get surjectivity here. Okay, the last column is bijectivity, and this is the easiest one because bijective, the definition is that it's just injective and surjective. Well, let's see. Checkmark X, nope, not bijective. How about this one, C, checkmark, checkmark. Hey, it is. So it is bijective. D, XX, so not bijective. And E, X check. It's not going to be injective, so it's not bijective. So actually, the only one that's a bijection, right, is option C. Whew. Okay. So, and I guess, let's put in here B, just the explanation, right? Why was it not a relation? 7 is an image, but 7 is not an element of B, which implies not a relation. Okay, so now we got everything in there, all the explanations, we've got a whole chart. Whew, all right, we'll see you next time.